Okay. Example 1, I'm going to build your intuition about how to solve an exponential equation. And I just want you to keep in mind that as we're solving these equations algebraically, a lot of these equations are special cases. They're almost like handmade by the people who wrote this textbook so that they could be solved in this way. But the general way of solving an exponential equation is most properly done with logarithms, which you'll learn about next chapter. I keep saying that a lot. Oh well. Okay. So there's like a formal, general, this works in every situation type method. That's what logarithms are for. What I'm showing you today works only in special cases. Okay? The foundation of today's method is this bolded statement that I've written in your notes. This is very important. Okay? As long as the bases of two expressions are equal to each other, so as long as two expressions have the same base, their exponents should be equal as well. Okay? If you don't know what I mean by base, if I had something like 2 to the power of 3, the 2 is the base, the 3 is the exponent. Okay? So if I have two expressions that have the same base, their exponents should also be equal. Okay? I mean, a really obvious example would be like 2 to the power of 4 equals 2 to the power of x. What is x? Also 4. It has to be. It can't be anything but 4, because otherwise these two things wouldn't be equal. Does that make sense? Okay, so if their bases are the same, their exponents also have to be the same. Okay, and that's really important for what I'm about to show you. So A here, we're going to solve algebraically, not with a calculator, even though we could solve it with a calculator. We're going to solve 2 to the power of 4x equals 2 to the power of 2x plus 6. We need to figure out what value of x would make both sides of that equation true. And like I just mentioned before, if the bases are the same, you can be certain that their exponents are the same. Okay? So that makes solving this equation really, really simple, because I don't really have to even care about the bases, even though it might look a little intimidating. You're like, how do I get the exponents out? Okay? You don't really even have to care about the fact that there are bases there, because the only thing you're concerned about is when these two expressions are equal to each other. Right? If the bases are the same, the exponents are the same. So the equation I really have to solve is this. 4x equals 2x plus 6. Right? I need to figure out what value of x makes those expressions equal to each other. Make sense? Okay, and that's really easy algebra. Okay, bring the 2x over. It gives me 2x equals 6, and x equals 3. Right, dividing both sides by 2. That's pretty simple algebra. Okay? So your goal here when you're solving these exponential equations in this section, your goal is to make the bases of your exponents the same. If you can do that, you can equate those exponents. Yeah, I just slobbered. And then solve for your variable. Okay? Just to prove to you that this does work, let's test that value, x equals 3. We'll substitute it in the left and right side. So 2 to the power of 4 times 3 should equal 2 to the power of 2 times 3 plus 6. We're just going to test to see that's true. So this is 2 to the power of 12 equals 2 to the power of, this just goes to 6, and 6 plus 6 is 12. And we know that's true. With me? Okay, good. So that's a really easy one, because our bases were already the same. The 2's were the same in this case. This next example, the bases are not the same. And so we're going to have to change our approach a little bit.
Sorry, Mr. Guna, where did the 4x disappear to?
Where did it disappear to?
Yeah.
What do you mean? Right here?
No over.
No over, because it's 4x equals 2x plus 6, and then the next step is just 2x equals.
Oh, I brought the 2x over. 4x minus 2x is just 2x.
Oh.
Yeah. Just skipping a few steps there.
Yes.
Yeah. Okay, let's look at the next one. B, I've got 4 to the x plus 2 equals 64 to the power of x. So, like I said before, if the bases are the same, the exponents are the same, we can equate them and then solve. Is that the case here? No, I've got a base of 4 and a base of 64. Ugh. So, the bases are not the same, but I'll ask you, is there a way of changing 64 so that it becomes a base of 4?
Yeah.
How?
If we multiply the 4 by 16.
Okay, so I could rewrite 64 as 4 times 16. That's a little bit closer.
4 to the power of 3.
4 to the power of 3. That's even better. Right? 64 is a power of 4. Right? It's 4 to the power of 3. Or it's a multiple of 4. Maybe that's a better way of saying it. Right? So what I can do is I can make a replacement here. I can rewrite 64 as 4 to the power of 3. And notice what happens. Right? The left side just stays the same. And then I have 4 to the power of 3. That was what 64 was. And that was raised to the power of x. And again, the intention of doing this is so that the base on the left and the right are the same. And we've achieved that here. Good how that works? Okay. So exponent laws tell me what happens with this 3 and this x.
Multiply.
Yeah, you multiply them. Okay, so that's 4 to the power of 3x. And now I have what I had in the last example. The bases are the same. Therefore, what do I know about their exponents?
They gotta be equal.
They're also the same. They have to be, right? So the only thing I care about solving is this guy up top. When these two expressions are equal. That's the only thing I care about solving. So that's really easy algebra. Okay, I bring the x over. So I have 2 equals 2x. And then divide both sides by 2. Oops. X is just 1. Okay? And that will work back in this original equation up here. If I put in 1 for x, these two guys will be equal to each other.